What is light? I mean, we see it every day, but what is it? How does it move? What is it made up of? Is it a particle or is it a wave like sound? And what even is a particle or a wave? And how can we tell which one light is? This is the very question debated by great physicists such as Isaac Newton and Albert Einstein, and for a long time no one really knew the answer. As time went by, more and more experiments were done, but the results were really puzzling, with some experiments suggesting that light was a particle, while others seemed to show wave like behaviour. This was until an English physicist named Thomas Young devised the double slit experiment. But what is the double slit experiment? Does it prove light to be a particle or a wave? And how? In the late 1600s, Isaac Newton proposed that light was a stream of particles in his book Optics, but at the same time, a Dutch physicist proposed that light was in fact a wave. Later on, Einstein proposed that it had to be a particle because of a phenomenon known as the photoelectric effect, in which light only displayed particle behaviour. So, what actually is it? The experiments were all seemingly valid, yet they all pointed to a different conclusion, whether it be particle or wave. This was a physicist named Thomas Young devised a way to settle the debate once and for all. Let's put up a wall, and that wall blocks anything trying to get past it. But there is two slits a certain distance apart from each other where a particle or a wave could pass through. Behind this wall, we have a detector screen which will show exactly where the particle or wave hit. Now imagine we have a cannon at the front. If we were to fire something at random that behaved like particles, let's say marbles, we would expect to see two defined lines directly behind the two slits. If a wave was fired, we would see something a little trickier. If we fired a wave, once it hit the wall, it would split up into two smaller waves, each coming from one of the slits in the wall. When these two waves meet, one of two things can happen. A transverse wave, of which we are dealing with here, moves in an up-down manner, kind of like this. Right now, I'm showing you from an above view, so you can see the interference pattern a bit better. When two of these waves collide, they either add together or collapse entirely. When the peak of a wave collides with the peak of another, they add together to form a larger peak. And when two troughs add together, the result is a deeper trough. But when a peak and a trough collide, the result is a collapse in which the wave no longer exists. When the waves from each slit collide with each other, the peaks get bigger or the troughs get deeper, but in certain areas a peak and a trough cancel each other out. This causes the pattern on the detector wall to look a little like this. This is known as an interference pattern and is caused by peaks and troughs registering as bright spots on the detector wall, while the dark strips are caused when a peak and trough cancel each other out. We can see this here, where we can see two peaks overlapping, and here two troughs overlapping. And all of these points make a line that points directly to the central maximum on the detector wall. More of these lines can be seen going diagonally, which makes the bright stripes to the sides of the slits. In these places, however, in red, we can see that a peak overlaps a trough, and subsequently, on the detector wall, there would be a dark spot. These stripes on the detector wall aren't made of tiny dots, such as the stripes made of particles were. So, which is it? When you fire photons out of the cannon at random, do they behave like particles, or do they behave like waves? The answer might be a bit difficult to understand. The photons that were shot out behaved like both particles and waves. The pattern on the back wall resembled an interference pattern, yet each stripe was made up of individual particles that formed one strip, rather than being defined stripes. At this point, no one really knew what was going on, but it was suggested that perhaps the particles hit the detector wall in that way because they were interfering or bumping into one another, causing this peculiar wave particle pattern. So instead of shooting photons out all at the same time, they decided to shoot photons out one at a time so that each particle or wave would not interfere with another particle or wave. So they shot each one out one at a time, but by the end of it, have a guess what emerged on the detector wall? The interference pattern. Physicists were baffled, and no one could really come up with a good explanation for the occurrence. It was only until a young graduate, Edward Schrödinger, proposed that perhaps the photon goes through both slits in clouds of probability, and the act of measuring at the detector wall causes the wave function to collapse into particle form. The wave function is basically a mathematical description of where a particle is and what it is doing, and can be written like this, but we won't go into that. Anyway, at first Schrödinger's concept was not very highly regarded, but soon as more and more evidence pointed towards his concept, physicists started to take it seriously. But physicists wanted to know more, such as how this actually worked, so they set up detectors near the slits behind the wall. However, to add to the mystery, as soon as the detectors were turned on, the photons behaved solely like particles, appearing as two bright strips on the detector wall. And when physicists decided to leave the cameras on, but not record any data, something even stranger happened. The interference pattern was back again. If we look and record the data, the wave function collapses, but if we don't, it stays as a wave. If we look at what the detector is recording, it behaves like a particle, but if we don't, it behaves like a wave. It is as if the particle knows we're observing it. Unfortunately, that's all we have time for, but if you want to know more about how exactly the double slit experiment works in more depth, take a look at part 2 of this video.